In September 2020, the CEO of Nvidia, Jensen Huang, stepped in front of the world to announce the acquisition of a lifetime. It was a $40 billion buyout of a quiet, invisible British company called ARM. But within hours, the entire global tech industry erupted in absolute panic. This wasn't just another corporate merger. This was an attempt to seize the most valuable piece of real estate in the history of technology. Google, Microsoft, and Qualcomm immediately launched a coordinated legal war to block the sale. They knew that if Nvidia controlled ARM, the game was over. But why? To understand the panic, you have to understand the paradox. ARM is the Switzerland of silicon. They do not manufacture a single physical chip. They do not run massive foundries or manage thousands of factory workers. Instead, they sell pure math. They design the architectural blueprints that run 99% of the world's smartphones. Every time you unlock your phone, every time a car applies its ABS brakes, every time a server processes a cloud request, you are using ARM's logic. Before 2020, ARM was owned by a Japanese conglomerate called SoftBank. Its CEO, Masayoshi Son, had bought it for $32 billion in 2016. He famously called it his crystal ball. He knew that whoever controlled these blueprints controlled the future of artificial intelligence. But when the world's governments looked at Nvidia, a company that actually builds its own chips, they saw a monopoly in the making. The Federal Trade Commission and the British government declared that ARM's neutrality was too important to lose. If Nvidia bought them, they could theoretically cut off access to their competitors. It was the greatest toll booth in the history of capitalism. In February 2022, the deal was officially killed. Nvidia walked away, and the world breathed a sigh of relief. But the question remained: how did a tiny, struggling British startup become so powerful that the world's governments had to step in to stop its sale? To answer that, we have to rewind the clock 40 years. We have to go back to 1985, to a rainy pub in Cambridge. And we have to witness the moment two engineers accidentally built a miracle, because they were too poor to do it the right way. To understand the $40 billion war, we have to look at a 1981 British computer called the BBC Micro. It was the heart of the UK's computer literacy project. It was built by a tiny, ambitious company in Cambridge called Acorn. In England, they were essentially the Apple of the 80s. But by 1983, the BBC Micro was aging rapidly. Across the Atlantic, the IBM PC was beginning its global conquest of the business world. Acorn knew they needed a successor. They needed a processor that was faster and more powerful than anything on the market. They initially went to the kings of the industry. They asked Intel for access to their new 8286 chip, hoping to build their next machine around it. But Intel didn't see a partner. They saw a nuisance. They looked at this tiny British startup and essentially laughed them out of the room. That rejection would become one of the greatest strategic blunders in the history of silicon. Intel had handed Acorn a death sentence. But instead of giving up, two brilliant engineers, Sophie Wilson and Steve Ferber, decided on a suicide mission. If Intel would not sell them a processor, they would just design their own from scratch. The problem was the math. Intel had thousands of engineers and millions of dollars. Acorn had a team of 12 and almost no budget. To survive, they had to do something radical. They had to make the chip incredibly simple. They began stripping away every unnecessary instruction Intel used. They called it the Acorn RISC Machine, ARM. It was based on a new philosophy, reduced instruction set computer. They worked in a state of constant pressure, knowing that if this chip failed, the company would vanish. On April 26, 1985, they finally received the first prototype from the factory. They plugged it into a test board at their Cambridge lab. The team held their breath. They expected smoke. They expected a crash. Instead, the screen flickered to life. The chip was running perfectly. But then Steve Ferber noticed something that should have been physically impossible. He looked down at the workbench. The main power cable for the chip was completely disconnected. It was sitting on the wooden table inches away from the board. The engineers were terrified. They thought the board was possessed, but the truth was even more profound. The ARM architecture was so mathematically efficient, so stripped of waste, that it didn't even need a power supply to boot up. It was pulling the tiny fraction of a volt it needed directly from the leakage current of the surrounding components. It was running on static air. Intel had spent billions building high-powered engines that required massive cooling. Acorn had accidentally built a miracle that didn't even need a plug. At the time, they didn't realize they had just solved the greatest problem in mobile computing 20 years before it existed. They had the miracle. Now they just needed a partner. And in 1990, a billionaire from Cupertino was about to change everything. So, how did a handful of British engineers accidentally beat a multi-billion-dollar giant? It comes down to a fundamental war of philosophies. This is the battle between CISC and RISC. In the early 1980s, the undisputed king was Complex Instruction Set Computer, or CISC. Intel's architecture was built on a simple premise: make the computer do as much work as possible in a single command. Think of it like hiring an incredibly expensive, world-class master chef. You give the master chef one complex command like bake a cake. That single command is massive. The chef has to stop what he is doing, find the flour, crack the eggs, mix the batter, and manage the oven. While the chef is working on that one complex task, the rest of the kitchen sits idle. It generates massive heat and wastes enormous amounts of time. In the world of silicon, this is called variable length instructions. Some take a little time, some take a lot. It is unpredictable. Acorn could not afford the master chef. They didn't have the budget to design complex decoders. So they looked at a radical research project from Berkeley and Stanford called RISC, Reduced Instruction Set Computer. Instead of one master chef, RISC uses a high-speed assembly line of fast food workers. One worker cracks the egg, the next stirs, the next bakes. No one is ever idle. Every instruction is exactly the same size. Every instruction takes exactly one clock cycle to complete. This is the secret of pipelining. While one worker is baking the first cake, the worker behind him is already mixing the second. The result was a chip that was 10 times simpler than Intel's. Yet because it was so efficient, it could run at incredible speeds. But there was a side effect that Acorn engineers didn't even plan for. Because the instructions were so simple, the chip didn't need a massive control unit. A smaller chip means less distance for electricity to travel. Less distance means less resistance, and less resistance means no heat. In 1985, when the world was obsessed with gigahertz and brute force, Acorn had built a chip that could run on the power of a single AA battery. To the giants at Intel and IBM, this looked like a weak toy. They thought RISC was a dead end for real computing. They were wrong. They didn't realize that the master chef was about to meet his match in a device that hadn't even been invented yet. It was a ticking time bomb, waiting for a savior. And in 1990, that savior arrived in the form of a struggling company from Cupertino. By 1990, the miracle in Cambridge was facing a brutal reality. Acorn was running out of money, and the world's desktop computers were all powered by Intel. They had the most efficient processor on the planet, but they had no one to sell it to. The ARM chip was a solution looking for a problem. Then, 3,000 miles away in Cupertino, a struggling Apple was working on a project that everyone thought was impossible. They were building the Newton. It was the world's first true personal digital assistant, a handheld tablet that you could write on with a stylus. But Apple had a massive physical problem. If they used an Intel chip, the device would require 6 AA batteries and would get hot enough to melt the plastic casing. Larry Tesler, the lead scientist at Apple, heard rumors of a tiny team in England who had built a chip that didn't even need a power supply to boot up. Apple didn't just want to buy the chip. They wanted to own the architecture. In November 1990, Apple, Acorn, and VLSI Technology formed a joint venture. They pulled the engineers out of the pub and into a new company. They officially named it Advanced RISC Machines, ARM. The mission was clear: build the brain for the Newton, but the Newton was a colossal commercial disaster. It was too expensive, the handwriting recognition was terrible, and the world simply wasn't ready for a tablet in 1993. Apple eventually killed the project, but while the Newton died, the chip inside it survived. ARM realized that if they stayed tied to one product, they would die with it, so they made a decision that changed the world of business forever. They decided they would never manufacture a chip again. Instead, they would become an IP licensing company. They would sell the math to anyone: Nokia, Samsung, Texas Instruments. Anyone could build an ARM chip as long as they paid ARM a small tax. This was the birth of the Tollbooth model. ARM sat at the center of the world, quietly collecting pennies on every mobile device sold. By the late 90s, ARM was in the Nokia 6110. They were in the Game Boy Advance. They were everywhere. They had become the invisible standard, and they were just waiting for one more device to launch them into the stratosphere. In 2007, Steve Jobs walked onto a stage in San Francisco to announce 3 revolutionary products. But in reality, there was only one. The iPhone was coming, and ARM was the only architecture on Earth that could make it breathe. In 2005, Steve Jobs approached Intel with a secret proposal. He wanted them to build the chip for a revolutionary new phone. Intel's CEO, Paul Otellini, looked at the numbers and said no. He didn't believe the iPhone would sell enough units to cover the development costs. It was the most expensive no in the history of business, because Apple didn't give up. They went back to their old partners at ARM. When the iPhone launched in 2007, it wasn't just a phone. It was a pocket-sized supercomputer that ran on a fraction of the power of a laptop. Suddenly, every company on Earth, Samsung, Google, and Motorola, was panicking. They all needed to build an iPhone killer, and they needed it immediately. But there was a problem. If they went to Intel, the batteries would die in 2 hours. There was only one architecture that worked. This was ARM's moment of total victory, but they didn't do what Intel did. They didn't build a factory and try to sell chips to everyone. Instead, they perfected the Tollbooth model. They became the Switzerland of Silicon. Think of it like this: Intel sells you the finished car, but ARM sells you the engine blueprints, the chassis design, and the wiring diagrams. You buy the blueprints, you customize the car, you put your own logo on the hood, and then you build it in your own factory. This allowed Apple to create Apple Silicon and Qualcomm to create Snapdragon. They are rivals, but they are both built on ARM's DNA. By 2012, ARM was effectively a global tax. Every time a smartphone was sold anywhere on the planet, ARM collected a few cents in royalties. It was the perfect business. They had zero inventory, zero factories, zero shipping costs. They just emailed code and collected billions. While Intel was still trying to force their heavy, hot processors into phones, ARM was quietly taking over everything else. They moved into smart fridges, smart watches, car engines, even the Mars Ingenuity helicopter. If it ran on a battery, it ran on ARM. Intel had lost the mobile war, but they weren't worried, because they still owned the high-performance world, the laptops, the desktops, the servers. Intel believed that ARM was only for mobile. They thought RISC architecture could never be powerful enough to run a pro laptop or a massive data center. They were wrong again, because in 2020, Apple decided it was time to stop being a customer and start being an assassin. The M1 chip was coming, and it was about to commit a public execution of the x86 architecture. For 30 years, the world of computing was divided by a wall. ARM was for toys, phones, and tablets. Intel's x86 was for real work. But behind the scenes, Intel was hitting a physical limit. To get more power, they had to pump more electricity through the chip. This created a heat wall. Intel laptops became famous for thermal throttling, where the chip slows itself down just to keep from melting. In November 2020, Apple decided to tear the wall down. They announced the M1, the first ARM chip designed specifically for a Mac. The PC industry laughed. They thought a phone chip could never run Final Cut Pro or Photoshop. They didn't understand the decoder advantage. Because ARM instructions are all the same size, the M1 can decode 8 instructions at the exact same time. Intel's x86 can only do 4. But the real secret was unified memory. Instead of the CPU and the GPU being separate chips, Apple fused them into one single slab of silicon. This removed the data traffic jam. The memory was right there, inside the chip. The result was a MacBook Air with no fan that was faster than a $3,000 Intel laptop. It was a massacre. The M1 used 1/4 the power of Intel, but delivered twice the performance. The 18-hour battery life was finally real. Intel panicked. They launched a series of "I'm a PC" commercials trying to mock Apple, but the market had already moved on. Within 2 years, ARM architecture had captured 15% of the global laptop market. And then, the Windows world woke up. Qualcomm released the Snapdragon X Elite. For the first time, Windows laptops were running on ARM architecture and beating Intel at their own game. The era of x86 dominance is over. We are living in the efficiency era, but ARM isn't satisfied with just your laptop. They are moving into the final frontier, the place where the world's most powerful AI is born, the data center. Nvidia couldn't buy ARM, so they decided to use ARM to build the most powerful AI computer in history. The Switzerland of Silicon is now running the brain of the future, and that brings us back to the original question. If one company owns the math that runs everything, do we really own our technology at all? We began this story with a $40 billion panic, a world where a single company in Cambridge was too powerful to be bought. Today, the ARM architecture is no longer just a mobile standard. It is the foundation of the modern world. From the tiny sensors in your smart home to the massive AI superclusters at Nvidia and Amazon, ARM is the invisible air we breathe. But for the first time in 40 years, the Switzerland of Silicon is facing a new kind of threat, and it isn't coming from Intel. It is called RISC-V, an open-source architecture that no one owns. It is the Linux of the chip world. If ARM is a toll booth, RISC-V is a public highway, and companies like Meta and Google are starting to look at the exit ramp. But ARM has a 40-year head start. Their software ecosystem is a moat so wide that even the biggest tech giants struggle to cross it. They accidentally built the perfect machine because they didn't have the money to build a complex one. They proved that in a world obsessed with brute force and raw power, efficiency is the ultimate weapon. We started this journey in a rainy pub in 1985, a tiny team with a disconnected power supply running a chip on static air. Today, that miracle is worth hundreds of billions of dollars, but its greatest trick wasn't the speed or the power. Its greatest trick was becoming so essential that we stopped noticing it was there at all. ARM doesn't make the devices you love. They make the devices you love possible. If you enjoyed this deep dive into the invisible monopoly, hit the subscribe button. We have a lot more stories to tell. Thanks for watching.